Okay, this section talks about exponential growth. We've talked about this before, and the formula is P equals ER to the T. And when we talked about this, and I was trying to find what worksheet it was, but I couldn't. But I made a little joke about using the formula BERT, like, because BERT is the who you're going to see in the scientific laboratory. So if you get those questions that are like talking about growth and things growing and decaying, you're like, oh, this is the formula you're going to use. The scientist is going to help you. So that's kind of the topic, but the questions are going to be written a little bit differently. And what you'll see is this is the type of question that might be on an FRQ. So let's say if dn over dt equals 1/3 n, and the initial value, so when t is 0, we get n is 300. Find the equation for n of t so I can figure out what the value is no matter what time, not just at 0 that I'm given. So the first thing we need to do is we need to separate the variables. So you see how here's an n here and there's an n on this side? And then even though this is a t and there's no other t, but I can keep this constant. And so I'm going to divide by n and multiply by dt at the same time. So divide by n, multiply by dt, and then what I get is dn over n equals 1/3 dt. Now on an FRQ, just that move right there of separating the variables will give you a point, and each FRQ is worth 9 points. So that's the first thing you want to do. So I'll make little notes right here. Separate variables. Okay. Then the second thing is we're going to take the integral. Okay. So to take the integral of both sides, whoop, whoop, okay. This is like 1 over n. What's the integral of 1 over n? Well, it's ln of n equals, and then this is going to be 1/3 t plus c. So now we're going to figure out what c is, because we're trying to find the equation, and what we have to do is figure out what that c is. So what we do is we're going to plug 0 and 300 in. So my initial value, ln of 300, equals 1/3 of 0 plus c. And so what we find out is c equals ln of 300. So now I can rewrite this equation, I can rewrite this equation down here, filling in the terms that we know. ln of n equals 1/3 t plus ln of 300. All right? So we still want to know what n of t is, so I have to solve for n. We want to get n by itself. Okay, so what is it that we did? We took the integral. Okay, then we found c, right, by plugging in. And then what did we do? We plugged in. Okay, then we rewrote the equation. Rewrote equation with the c replaced, right? With the c plugged in. Okay. Now what we're going to do is we're going to solve for n, or whatever variable we're looking for. It just so happens that this equation has an n in it. So how do I get rid of an n? What we're going to do for that, and I'll make a little notes for what I do for solving for n, we're going to take or apply e to both sides. Okay, so we're going to take e of this side and e of this side. So this is like, when I do that, this is now the exponent, e to the power of this, e to the power of that. And what happens? Let's simplify this. Well, we know where there's an e and an ln together. Those cancel out and you just get an n. And now this is a plus, so I can rewrite this as e to the 1/3 t times e to the ln of 300. So what happens here now is that this e and ln cancel, and so you get n equals e to the 1/3 t times 300. This is a constant, and typically you write the constant in the front. So we're going to get n equals 300 e to the 1/3 t. So why do I say this looks like the formula BERT? Because this is our initial value. Remember, at the very beginning, n of 0 was 300. So our initial or beginning value, E, then the rate or the proportion, okay, is 1/3. And then all we have to do is plug in whatever T for time is on that problem. And so that's how you solve these types of problems. So what did we do? We applied E to both sides, and then we simplified. And by simplifying, I mean I crossed out this E to the ln, and then I moved the constant to the front. Move constant to the front. Okay? So that's how you solve these exponential growth. And really, I should probably call them, because if I look them up on the internet or something, I'm going to look for separation of variables. That is a key thing, you know. It seems so easy. Put all the y's on one side, all the x's on the other. In this case, all the n's on one side, all the t's on the other. Let me see. I could do another problem. Let's see if we have something like this. Let's say I have dx dt equals 1/5 x. And then x at sub 0, this is another way of saying the initial value is, I don't know, say 2,000. And then we want to find what was the, I wonder how I word this problem. What was the rate of change? Let me see. Should have made pause for. Okay, let's say that the rate of growth of plants in the area is at 1/5, and the initial number of plants in the forest was 2,000. I want to know what is the number of plants that there's going to be in this forest area in 10 years. So I'm just going to go through the same process. We're going to separate the variables. We're going to divide by x and multiply by dt. So we get dx over x equals 1/5 dt. Okay, the next step was take the integral of both sides. So I'm going to get ln of x equals 1/5 t plus c. I'm going to use the initial condition. Oh no, before I do that, I'm going to take, oh yeah, I got to solve for c. We're going to use the initial condition. So the initial condition, I have ln of 2,000 equals 1/5. Now initial means that t equals 0. T equals 0 is the initial measurement, the initial time, the beginning time. So plus c, so we're going to find out that c equals ln of 2,000. All right, now we can rewrite the equation. I'll just rewrite it over here, and we get ln x equals 1/5 t plus ln 2,000. Now we're going to apply e to both sides, and we get x equals e to the 1/5 t times e to the 2,000. No, e to the ln 2,000. The ln's cancel. So then I'm going to get x equals e to the 1/5 t times 2,000, or 2,000 e to the 1/5 t. So now that I have my equation, I can just plug in 10, and I go x equals 2,000 e to the 1/5 times 10, or that's going to be x equals 2,000 e to the 2. And now at this point, I'm going to need, I probably want to see what I wrote, huh? All I did was plug in 10 for t. 10 times 1/5 is 2. Then I need a calculator to figure out what that is. So when I typed this into the calculator, I got 14,778. So even though this area started with trees in the forest, or whatever I said, did I say trees? It was started with 2,000. 10 years later, if they continue to grow at the rate, that 1/5 rate, then in 10 years there'll be over 14,000 trees. So that's the process. Hopefully this video will help, and we'll go over any questions you have. Have a great day.